Minesh Bismillahirrahmanirrahim. Dear students, parents and well-wishers, thank you very much for listening the lectures and for your comments. लास्ट लेक्चर में स्टूडेंट्स हमने एटॉमिक ऑर्बिटल हाइब्रिडाइजेशन और उसकी थोड़ी सी इम्पोर्टेंस के ऊपर गुफ्तगू करने की कोशिश की थी. दैट इज़ वाई एटॉमिक ऑर्बिटल हाइब्रिडाइजेशन इज़ नीडेड इन केमिस्ट्री. तो आपने उस लेक्चर में देखा कि एटॉमिक ऑर्बिटल हाइब्रिडाइजेशन उन लिमिटेशंस को एक्सप्लेन करती है जो वैलेंस बॉन्ड थ्योरी में पाई जाती हैं या जिनको वैलेंस बॉन्ड थ्योरी एक्सप्लेन नहीं कर सकती है. तो लास्ट लेक्चर के एंड पे हमने टाइप्स ऑफ हाइब्रिडाइजेशन पढ़ी थी. अगरचे बहुत सारी टाइप्स हैं, लेकिन जो तीन बेसिक और फंडामेंटल टाइप्स ऑफ हाइब्रिडाइजेशन हैं, तो उनमें से हम आज एक के ऊपर गुफ्तगू करेंगे और वो है sp3 हाइब्रिडाइजेशन. तो sp3 हाइब्रिडाइजेशन पे हम आज बात करना चाहते हैं कि ये क्या चीज़ है. As the name of the hybridization indicates, sp3 hybridization is the simplest form of hybridization in which one s orbital, which is 2s, and 3p orbitals, which is 2px, 2py and 2pz, intermix with each other and form 4 new hybrid orbitals of same shape and same energy is called sp3 hybridization. तो वो हाइब्रिडाइजेशन जिसमें एक s और तीनों p आपस में इंटरमिक्स हो जाते हैं और 4 न्यू एटॉमिक ऑर्बिटल्स बनाते हैं विद द सेम शेप एंड सेम एनर्जी इज कॉल्ड sp3 hybridization. The same can be explained in the form of a figure. That is, this is 2s orbital which is spherical in shape. This is 2px orbital which is dumbbell in shape. This is 2py orbital which is also dumbbell in shape, and this is 2pz orbital which is also dumbbell in shape. These 4 orbitals which have different shapes as it is indicated in the figure and different energy. You know, 2s has low energy, 2p has high energy, and all the 3p orbitals are degenerate orbitals and they possess equal energy. So these 4 intermix with each other and they form 4 new orbitals having same shapes and same energy. So this is one sp3, this is second sp3, this is third sp3 orbital, and this is fourth sp3 orbital. Each sp3 orbital consists of two lobes, and as you know, this lobe is nothing, it shows the presence of electron, and it simply shows the electron density. So one is bigger lobe, the other is smaller lobe, and when all these four atomic hybrid orbitals, they give a shape like this one. This is one sp3, second, third and fourth sp3, and if you look it carefully, it gives a tetrahedral shape with all the bond angles 109.5 degree. So all the four sp3 orbitals have same shape, same energy, and they are tetrahedral, and all the bond angles are 109.5. And another important aspect of sp3 hybridization is that all these four sp3 are non-planar structure. It means that two of the sp3, they are in the plane of the board, that is two of the sp3 are like this one sp3, second sp3. The third sp3 is out of the plane and it is above the plane, and the fourth sp3 is below the plane, and these two are out of the plane, one above and one below, and the other two are in the plane. Hence it forms a non-planar structure. So this is known as sp3 hybridization. sp3 hybridization can explain the structures of methane molecule, ammonia molecule, and water molecule. Their shapes as well as their bond angles can be easily explained on the basis of sp3 hybridization. Let us look at the structure of methane molecule. All of you know atomic number of carbon is 6. So if I write the electronic configuration of carbon atom, then the electronic configuration of carbon atom is 1s2, 2s2, 2px1, 2py1, and you know this is according to the Hund's rule, and 2pz is empty, and it is the ground state electronic configuration of carbon. Now one of the 2pz is empty, so carbon can go into the excited state by shifting one of its electron from 2s orbital to the 2pz orbital. So the new configuration will be 2s1, 2px1, 2py1, and 2pz1. It is the excited state of carbon. Now in excited state, all these four orbitals intermix with each other and form four new hybrid orbitals, each having one electron, and all these are sp3. It is the hybridized state of carbon, and all these sp3, they will naturally forming the tetrahedral configuration, and they have same shape, same energy, tetrahedral 109.5 angle, and they form a non-planar structure. So these four on the carbon will be like this one, this is one sp3, this is second sp3, third sp3, and fourth sp3. Now each of these half filled sp3 of carbon now overlap with 1s1 half filled of hydrogen to form four separate sigma bonds like this one. So each of the sp3 now will overlap with hydrogens, and the atomic orbital of hydrogen is 1s1. Both the electron of sp3 and hydrogen will form a pair. They will have opposite spin, and now they will become stable and form four new covalent bonds. So the structure of hydrogen will look like this one, and the methane molecule will form a tetrahedral geometry. All the hydrogen bond angles will be 109.5 degree. They will be non-planar. Two of the hydrogens will be in the plane of the board, and one of the hydrogen will be above the board, and the other hydrogen will be below the board, and it form a non-planar structure. So methane molecule, as its structure has been determined by the X-ray analysis, shows that it is a tetrahedral structure with all the 109.5 bond angles, and it is a non-planar structure. So it can be very well explained on the basis of sp3 hybridization. Similarly, the structure of ammonia can be well explained by the sp3 hybridization. Now, if we consider the ammonia molecule like this one, structure of ammonia, then electronic configuration of ammonia, electronic configuration of nitrogen, atomic number 7 will be 1s2, 2s2, 2px1, 2py1, and 2pz1. This is ground state configuration of nitrogen. Now excited state in nitrogen is not possible, as it has no empty or vacant orbital, and all of you know that an excited state can only be found when an atom possesses one or more empty orbitals, as in case of carbon. So nitrogen will directly now go to the hybrid state, and all the four orbitals will intermix with each other, forming four hybrid sp3 orbitals. But now the difference is that one of the sp3 of nitrogen will have a pair of electron, and the other three sp3 of nitrogen are half filled, so the structure of nitrogen will be like this one. This contains a pair of electron, it is half filled, it is half filled, and it is also half filled. As nitrogen has three half filled orbitals, so these three half filled sp3 orbitals of nitrogen now overlap separately with the 1s1 half filled hydrogen atoms to form three sigma bonds. So these three sigma bonds will be formed as shown in the figure like this one. So one hydrogen, second hydrogen, and third hydrogen now will overlap and form ammonia. Now since ammonia contains one lone pair, so due to presence of lone pair of electron, the greater lone pair bond pair repulsion will reduce the bond angles from 109.5 to 107.5 degree, and it becomes a pyramidal molecule. And you know that X-ray analysis has confirmed that ammonia is a pyramidal molecule, and all its bond angles are of 107.5 degree, and a lone pair is present on it. So atomic orbital hybridization, especially sp3, can explain the formation of ammonia molecule. In case of water, two lone pairs will be present on oxygen atom, and so due to the presence of two lone pairs in case of water, the bond angle further reduces to 104.5 degree. So sp3 hybridization is quite successful in the explanation of the molecules like ammonia, water, pH3, NH3. All these can be explained on the basis of sp3 hybridization. In the next lecture, inshallah, we will talk about sp2 hybridization and its applications. Thank you, dear students. Allah Hafiz.